Okay, so in this video, we will be talking about solving logarithmic equations, and we're going to go ahead and look at some examples on how to solve them. So our first equation is going to be log 2 of x plus log 2 of x minus 3 is equal to 2. So how will we go on and solve this? Well, we're going to use basic log properties. And since we have log plus a log with the same base, it is going to be multiplication. So we are going to get log 2 of x times x minus 3 is equal to 2. And simplifying the inside, we get log 2 of x squared minus 3x equals 2. And now to get rid of the log, we simply just have to exponentiate it, which is going to give us x squared minus 3x is equal to 4. And we're going to go ahead and move 4 to the left side, which is going to give us x squared minus 3x minus 4 is equal to 0. And seeing this, we can go ahead and factor this equation where we have a solution of x minus 4 times x plus 1. And we solve for x now. We get x is equal to positive 4 and negative 1. So we want to go ahead and verify that that is indeed a solution to our equation, and which isn't. Since we may have extraneous solutions, we want to verify which is a solution. So we're going to plug in 4. So log 2 of 4 plus log 2 of 1 equals 2. And the log of 1 is simply 0, plus the log of 2 of 4 is 2, since we have 2 log 2 of 2 is simply going to give us 1, and we're going to simply get 2. So we have that 4 is a solution. Now we're going to go ahead and look at negative 1. So let's go ahead and verify that negative 1 is a solution. So we have log 2 of negative 1 plus log 2 of negative 4. And since we can't have negative logs, we basically get no solution since the number x cannot be negative. So seeing that it is log of negative 1 and log of negative 4, we basically don't get any real values because the graph of logs usually look like this. And they never touch the negative axis unless they're shifted to the left or right. But since we have x minus 3, it is more commonly to be shifted to the right. So we basically say that x does not equal negative 1. And we're going to go ahead and look at another example, which is log 3 of x plus log 3 of x, and that equals 2. So here, we can go ahead and just use the same property, which is multiplying x and x, since we have the same base, and it is addition. If it were subtraction, we would have to divide. But we have log 3 of x squared is equal to 2. Now we exponentiate it, which is going to simply cross out 3 and log of 3, leaving x squared, and 3 squared, which is 9. And we get that x is equal to plus or minus 3. And we want to verify which is which. And seeing that there is nothing that can make the negative positive, we can go ahead and assume x cannot equal negative 3. And here we have log 3 of 3 plus log 3 of 3, which is simply going to give us 1, and 1 plus 1 equals 2. So we see that that is one of our, well, our only solution, and we are going to just keep looking at several examples that are like that one, so we get a little bit of practice knowing and understanding how to solve logs. So another example is log 15 of 4 minus x, and that is equal to log 15 of negative 2x plus 2. So here we can't really get a general solution unless we move log 15 to the right, or just exponentiate everything to the power of 15, which is simply just going to cross out the 15. So now we are left with 4 minus x is equal to negative 2x plus 2. And now we are just going to go ahead and solve a linear equation where we have to add 2 to both sides, which gives us positive x, and subtract 4 from both sides, giving us negative 2. So here, now we have a equation where we could solve and get a real value from. So we get log 15 of, and we saw that x was equal to negative 2. So 4 plus, or 4 minus negative 2 is 4 plus 2, which is positive 6. And that equals log 15 of negative 2 times negative 2. That's 4 plus 2 is 6. So we get that x equals negative 2 is a solution, and our only solution to be exact. Now let's go ahead and look at another example. And we're going to have log of x plus 4 plus log of 3 is equal to 2. So we're going to go ahead and just multiply 3 times x plus 4, which is going to give us log of 3x plus 12, which is equal to 2. And we want to go ahead and exponentiate it since we have log 10. And whenever you just see log without a base, you're always going to assume that it has a base of 10, since when we have 10, we just ignore putting 10 down there. So here, now we just take everything to the power of 10, or exponentiate everything, which is going to leave 3x plus 12 and 10 squared. So we have 3x plus 12, and that equals 100. So now we're going to go ahead and have 3x, and subtracting 12 from both sides is going to give us 88. And x is equal to 88 divided by 3. So we're going to go ahead and see if that indeed gives us a solution. So let's go ahead and just verify that it indeed gives us a solution, which we're going to see. So we have 88 times 3, which is just 88, plus 12 gives us log of 100, which is the same thing as 2. So we have a solution, which is just 88 divided by 3. And I'm pretty sure you're getting the hang of this by now. Hopefully you are. So we're gonna look at one final logarithm, but try this one out on your own to see if you've gained some new solving skills. So here we have log 2 of negative 4x plus 2, and that is equal to log 2 of 5x plus 2. Try to give this one a go on your own. So we're going to just exponentiate everything, which is going to just raise everything to the power of 2. And we're going to have negative 4x plus 2, and that equals 5x plus 2. And then finding x, we just have to add x to both sides, where we have 2 is equal to 9x plus 2. Now here, what we just do is simply subtract 2 from both sides, but we can go ahead and see that if we do, we're going to get 0 is equal to 9x. And simply, x is equal to 0. And seeing that, we see that we just simply get log 2 of 2 is equal to log 2 of 2, which is simply our solution, or just 1 equals 1.